you think you might need a note for the final, you could write it down, or a sample question, you could write it down. This chapter, it was helpful to have a good calculator, but you don't have to. Number one, even the bad calculators can do that. Number one. But let's make sure you guys know how to plug it in the calculator. So what's cube root of 216? And for 36 to the 3 halves, now that one you can plug in the calculator too. Let's try and remember, what does this mean when it says to the 3 halves? What's another way of writing this? Okay, not quite. You got it backwards. It's the square root of 36 cubed. Like this. So remember when you have a radical and there's no number right there, there's an invisible 2 right there. So anyway, this. You don't need to know that to do this problem, but you kind of need to know it for the next problem. So you can use a calculator on both of these, by the way, because they come out nice. But number 2, not so much. Convert 5th root of 13 squared to exponent form. So how do I write this with just in the exponent? Oh, 13 is 2/5. Number 3. Okay, can we do this one on a calculator? Partially. You guys remember how to do it without a calculator? The tree. So this is the part you can do on the calculator. 3 squared of 5. But what do we do with p squared?
3p squared.
Okay. What was the invisible root right here if there's no number? 2. So remember we just did, basically it's 2 divided by 2, which is 1. So that means 1p comes out and no remainder. So nothing is left behind. You guys remember this stuff? This is January. This one is pretty similar. Okay, when it says simplify, that means no decimals, by the way. So don't put a bunch of decimals on these. I'm not going to take it. Pretty similar. So the 28 just becomes 2 squared of 7. You leave a little space right there. Okay, so how would I do the x's? It would be 3 divided by 2. Let's go back to like 4th grade for a second. 3 divided by 2. How many times is 2 going to 3?
1.
With the remainder of 1. So that means 1 comes out, 1's left behind. So 1x, 1x. And guess what would happen to the y's? Same thing. So y. Just got my video banned. Negative 2 squared of 45. Minus 3 squared of 20. Minus 2 squared of 6. Okay, can a calculator do this? Yes, it can. But can't do number 6. So let's go through how you do it without a calculator. 9 times 5. So this one will be 3 squared of 5, but there's negative 2 in front. Negative 2 times 3, negative 6 squared of 5. This one will become become 2 square root of 5, but there's a negative 3 in front. Negative 3 times 2 is negative 6 square root of 5. And this one, 3 and 2, there's not any doubles there, so it just stays square root of 6. Can we do anything else? Like terms, those two can go together. This one cannot. It's got to be the same kind, square root of 5. Negative 6 minus 6 is negative 12 square root of 5. It's kind of like negative 6x minus 6x is negative 12x. Also, yeah, because everybody takes their math test at once, there won't be any spare nice calculators. I'm got like 2 right now.
Let's get there first.
You might, oh, it's a mistake. I have to, I'll tell the teacher that you can share. Or maybe you guys might be with me actually. Lots of 3s. The one we panic on, right? Alright, can this calculator do this? No. Alright, so on this first one, because of cubed roots, the cubed root of a negative is just going to be negative something, because negative times negative times negative. So this negative can kind of come out and become positive. So that's just that. So how am I going to do this one though? Whoops. So since it's a cubed root, we need a triple. So this will be 3 squared cubed root of 6. But there's a 2 in front. 2 times 3 is 6. Cubed root of 6. Swing and a miss. And this one will be 3 cubed root of 3, and there's a 3 in front of that one. So 3 times 3 is 9 cubed root of 3. Can we do anything else? Yeah, first, third terms are alike, so they're 12. 3 plus 9, 12 cubed root of 3 plus 6 cubed root of 6. Yep. That'll make for good washing. You guys ever watched Looney Tunes?
Yep.
Okay, what kind of problem is this? Distributive. So 3 square root of 3 times 4 is 3 times 4, multiply the normal numbers together, 12 square root of 3. And minus 3 times 3, square root of 3 times square root of 5. Anything else? No, that's it. Number 8. What kind of problem is number 8?
Foil.
It's a foil. Because there's 2 terms and 2 terms. Alright, first, what is square root of 2a times square root of 2a? 2a times the 7, 14a. Yeah, anytime you take a square root times itself, just gets rid of the square root. So that's first. Outside, what's negative 5 times square root of 2a? Negative 5 square root of 2a. It does not really do anything. Inside, negative 5 times 7 square root of 2a. Negative 35 square root of 2a. And then last, negative 5 times negative 5. Positive 25. Is there anything else that can be done?
The
Middle two are like terms, so we can put them together. Negative 5 of those plus minus 35 of those is negative 40 of those. The doozy of a test, wasn't it?
Yeah, I don't remember that one.
Blocked it out. Traumatic experience. All right. Can a calculator do number 9? Yes, it can. How do we do it without a calculator?
Multiply by square root of 5.
Yeah, you can't leave the square root on the denominator, so you multiply top and bottom by square root of 5. The top becomes 4 square root of 10. The bottom, what's square root of 5 times square root of 5? Times 3.
15.
Can we do anything else? No. If those two reduce, you could, but no, it does not. Number 10. 2 plus I. What does I mean? An imaginary number. I is equal to the square root of negative 1. So, for example, if we had square root of negative 10, that is equal to
Square root of 10.
I square root of 10. You don't want to put the I in the back because it looks like it's on the square root. Okay. What are we talking about? Oh yeah. How about I squared? What's that equal to? Negative 1, because when you square, the square root goes away. So yeah, if you ever get I squared. Now, how do we get the I off the denominator here? Lydia anticipated me pretty quickly. Right as I made eye contact, she's like, no.
Multiply by.
Give the people what they want. Remember how many views I got last time?
I looked at how it's
Like
described.
12.
Like how they described it.
More than that.
I know, that was an underestimate, really. We'll watch it 20 times.
Oh my gosh,
What?
game.
It's 122.
Are you serious?
Yeah, you have 122.
Oh, I thought that's how many people watch your videos.
You almost went crazy.
It's like somebody is stalking Lydia.
More than any other one.
Yes. Well, every other video, the picture is like
You
this.
doing that.
And then on that one, it's like Lydia, like,
It's not funny.
called
It was
clickbait.
very funny.
Every single time you talk about your YouTube channel, if somebody's different that's in the room that doesn't talk to me, it's always like, you're on his YouTube channel. I'm like, okay.
See, you're famous. That's how everybody knows you.
No, I know it's Will. Will always the one who says it. So he's like, you're on Mr. Jordan's YouTube channel. And I'm like, I know Will.
You told me yesterday. He was dropping some puns today. You guys missed out. They weren't any good, no.
He made a pun by Lowe's one time. We were driving there.
Using Lowe's.
Because we drove by Lowe's on trap shooting.
Trap
It
shooting,
was
yeah.
like, everybody has their high and lows. And then we're all
So terrible.
we're like, thank you for that, Will.
I like that one.
He usually gets rebuked in
It was,
Shut
the
up.
whole bus was like, I hate you, Will.
Because he does it all the time and people get sick of it.
We're like,
Okay.
I'm Austin.
Anyways, yeah, that's on that level. If you have two terms in the denominator to get rid of the square root or the I, you have to multiply by the conjugate, and to the top as well. The top, this would be a FOIL problem. Bottom kind of is too, but what's the first? 2 times 3. What's the outside? 2 times 2i. The inside, 3 times I. And the last, I times 2i. I times I makes I squared.
Which is negative.
Okay, the bottom, yeah, we'll fix it later. The bottom is FOIL also, but when you do conjugates, the outside inside cancel out, so really you just need the first and the last. So the first is 9, and the last is minus 4i squared.
No.
Okay, but what happens with these I squareds though?
Negative 1.
Right, it's like 2 times negative, so it's like minus 2. So 6 minus 2 is 4 plus 7i over, and this is like negative 4 times negative 1, so it's plus 4, so 9 plus 4 is
13.
Now, you could leave it like that. Sometimes they like you to, on these imaginary numbers, to split them up. It's like a complex, like you have the real and the imaginary part. They call it complex.
When do you know to do it?
I think most of the time
Just separate it?
that's that, but I feel like in older books I've seen it written like this more, and in newer books it's written like this more, so whatever. So maybe on the ACT it'll look like that.
Okay.
Alright, now we're in trouble. How do we fix that guy?
Times
Cube root.
If we multiply by a cubed root of 9, we get a cubed root of 81. Does 81 have a cubed root?
Yeah.
Did you times it twice?
You could do it twice, but there's a much easier way.
Did you times it by cube root?
You solve it first.
It's got 2 3's in it.
So square root of 3.
So if we give it just one more 3, it's going to be like 27. Does 27 have a cubed root? Yes. Yeah. You could do times 9 twice, but that'll make a lot of work in the future if you do that. So the top is distributing, so it's just 3 cubed root of 3, lots of 3's, plus cubed root of 9 over, well, it's cubed root of 27, but what's that? 3. That's why we did it, to turn it into a number. Does that reduce?
No.
Yeah, it's got to go into both of them if you don't separate them at least. So it doesn't really reduce like that. Unless you separate them, the left one reduce. Okay, we made it to the equation part. Alright, so on equations, kind of the goal usually is to get the square root by itself and then eliminate the square root. How could we get the square root by itself on this one? Divide by 5, because 5 is multiplied to it. So when you divide by 5, that goes bye-bye. So we get square root of k over 3 equals 1. So we got the square root by itself. How do I get rid of a square root? Square it. So the left side, square it goes away. The right side is 1 squared, which happens to be 1. And how do I solve that for? What divided by 3 equals 1? How do you get rid of a divide by 3?
Multiply by 3.
Times 3. Okay, when you use the square trick, like you square both sides, kind of an asterisk with this one. That's an asterisk, by the way.
That was a star.
Plus or minus, maybe?
No, that was the square root trick. So let me remind you of that one real quick. If k squared equals 9, k equals plus or minus 3. So that's the square root trick. This one is the squaring trick. Okay, that would actually be true, but what happens sometimes is if you get -4 and you square it, you get 16. But the square root of 16 is not -4. So sometimes
You just have to check it.
you're supposed to check it. Sometimes you get an answer that doesn't actually work. And you're supposed to plug it in. And it pretty much almost, well, not always, but usually has to do with squaring a negative. And it doesn't actually work. But if we plug 3 in, 3 divided by 3 is 1. Square root of 1 is 1. Times 5 is 5. So that does actually work. No problem, no problem. Number 13. Okay, this one caused us all kinds of grief. Any guesses for the first step?
Square.
Yeah, since both sides are into the square root, we can fix that real quick. Just square both sides. And we have p over 2. This is actually the point where we kind of run into issues. A couple ways we can do it.
Can you put a 2 up?
Hey, wait, over here? I mean, you could. I don't think it'd help you though.
Multiply by 2 first
Why would you multiply by 2?
to get p by itself.
To get rid of the
Yeah.
denominator? Yep, that's one way to do it. So, remember when you have like variables on both sides, you usually want to like put them together like this, right? So you could do this. Now, how do you do p over 2 minus 2p? P over 2 is basically 1/2 p. So 1/2 minus 2 is like -1.5 or -1.5 p. So that caused us issues. But you could do what Sam said and multiply both sides by 2, because what's going to happen? It's going to go bye-bye. So this times 2 would give us p equals 4p minus 60. Which looks much simpler, right? So that kind of cleaned up the mess for us. And then if we get our p's over here on the left, -3p equals -60 divided by -3. No. 20. And if you plug 20 back in, you get what? Square root of 10 and square root of 10
Yeah.
on both sides. So it works. Alright. Kind of hard to do heavy level math this time of day, isn't it? Or maybe any time of the day, but this might be worse. Probably should open that.
Give it a dead splash.
Don't do drugs, Sebastian. Alright, any ideas on this one?
Looks like he's on.
Square both sides, that gets rid of the square root. So we got 35 minus 2a equals a squared. How do
Where
we?
you put everything on one side?
Yeah, if you got a squared, x squared problem, you move everything to one side and then what? Factor or
Minus 35.
quadratic formula? Oh, gross. Usually they like to give you ones that factor though. Does this factor?
Yeah.
What multiplies into -35 that also adds up to 2.
A plus 5, A minus 5.
7 minus 5. So what A values would make this factor or this factor?
Same answer.
Not at the same time, that's why it was off.
-7.5.
Okay, think those are both gonna work?
Yeah.
Yes.
I don't think so.
They are.
If we plug in -7, so these guys weren't here originally. If we plug in -7, we get 35 plus 14 is 49. Square root of 49 is 7. -7.
It's close enough.
So the negative kind of screws it up. But if you plug in 5, 35 minus 10 is 25. Square root of 25 is 5, which equals 5. Yeah, that one works. Last. Well, in the other class I was in a hurry up mode, so I only did 15 and 18 with them. 17 is kind of a repeat of something we've already done anyway. We'll just do 15, 16, and 18. How about? That sounds like a plan. Now, you guys have a challenge here because somebody, or maybe a few people in the other class remembered how to do this one. I didn't think they would remember.
I don't remember if this or how
Me and Abby.
And Abby's not here.
I forgot this one.
Don't you do?
I didn't just write that class.
Isn't that like pretty swept around? Is it AC?
You're probably thinking of logs, and no, that wasn't. Actually, probably could find a way to do it with logs, but no, what?
Is it ACB?
That's logs. That was not this chapter. That was like, I don't know, chapter 10 or 9 or something. We'll get to that.
Abby, if you're watching this, I know you're disappointed.
This is your reason to stay, Abby.
Par for the course. Alright, what you do is you change them to the same base. So the base would be like 5 over here. So 125 is 5 to the what?
No.
5 times 5.
Third, come on.
No.
5 times 5 is 30.
I said third.
25.
Yeah.
Good job, Trey.
Then what?
That's what I said, to the third.
You said 30.
No,
You
I
said 30. You said 30.
You said 30.
There's nothing going
You
on.
can't come back from this, Sam.
He's innocent. Alright. Now, if these are both 5 to the something equals 5 something, then the something and the something would have to be equal to make these equal. So 3n minus 2 equals 3. Back to the basics here. So 3n equals 5. N equals 5/3. He meant 5 to the 3rd. Right, Sam?
Thank you.
How'd you get 5 times 5 equals 30?
I didn't. I said 5 to the third.
Ooh, everyone heard 30.
Yeah, everyone heard 30.
Mass hallucination. Okay.
Schizophrenia at its finest.
Number 6. True. Why is that? I don't know why that's in parentheses right now. Probably should be negative. We kind of used this trick already. Actually, if you have a nice calculator, you can fix it, but I think, unless the answer is messy. You guys know how to fix this one? Times the conjugate of the denominator, which just means put a,
Wait, when do you use the conjugate and then when do you just multiply by square?
when there's 2 terms at the bottom. You can't just multiply this by square root of 5 because it would be like square root of 5, 2 square root of
So
5.
more than one term used to
Yeah.
thing.
so the top, first on the top is -4. Outside is 2 squared root of 5. Inside is plus 2 squared root of 3. Last is negative square root of 15. Actually looks like calculator can't do this one because that doesn't simplify. And calculators aren't quite that good. Normal ones aren't. I'm sure there's good enough ones out there, but they're illegal on ACT. Okay, anyways, on the bottom you can just do first and last since they're conjugates. -2 times -2 is 4. Negative square root of 5, positive square root of 5, -5. Which 4 minus 5 is -1. And if you divide by -1, it would just switch all those signs. Can't fit it on here. That was a doozy. It's kind of mean of me to put that one on there. You agree? I concur. Okay, last one. Number 18. Okay. Maybe I should write this down for Abby's sake. You got a visual. What is the -1 gonna do to the... What shape did this make? Do you guys remember?
Went it backwards, didn't it?
Yeah, so that, whatever that's called. Kind of a half of a sideways probably. I just think of it like a slope of a hill. Anyway, what's the -1 do to the graph?
Go down one.
Down 1. So it would be option C. What does this -1 do to the graph?
This is reverse it.
Right one. It affects the x value, but it does the opposite of what it looks like. So it moves it right one, which is option.
B.
And then on the third line, if you make the whole thing negative, what's that going to do to it? If the whole thing's negative, it goes upside down. Remember when we did the sine functions and it was like negative sign went down? Anyways, there's a negative out in front of everything, it goes upside down. So that would be like option D. The +1 moves it left 1. And what if the negative is directly on the x? It flips the x in the x direction. So it's the A option. Slide to the left. Slide to the right.
Everybody clap your hands.